Hi, today we're going to be talking about coin problems. Now, at this stage in your Algebra 1 career, you might have come across simultaneous equations. And a lot of times you'll see this in the term of a problem involving different coin amounts or different cent amounts. And they're a great starting point because they really teach you the basics about how to work with any sort of simultaneous equation, right? Any sort of linear equation. And they make sure that you understand all of the basics and all of the things that can trip you up if you don't understand how to work with these types of equations. So, I'm going to go through a couple of problems in this video, go through strategies and tips, and through those strategies and tips, you'll see very, very important things to keep in mind when solving simultaneous equations, with the goal being that it'll be easier for you to solve these types of equations in the future. In particular, we're going to look on the magic we do with the coefficients, right? Those numbers next to the variables. That'll make our jobs a whole lot easier. So let's start with a sample problem. All right, let's say I know that I have 7 coins in my pocket, right? And they're all either dimes or nickels. This is a word problem, so I'm going to stop reading. I'm going to say, okay, I'm dealing with dimes or nickels, right? I'm going to say D for dimes and N for nickels. And I know that I have in total 7 coins, right? So the number of dime coins I have and the numbers of nickels I have must add up to 7. That makes sense. The value of the coins is $1.55. How many dimes and nickels do I have? Now, we have the first part. I have 7 coins in my pocket, represented algebraically. Now, how do we represent the value of the coins is 55 cents? Well, we know a nickel is worth 5 cents and a dime is worth 10 cents, right? So I could say the number of dimes I have times 0.1 plus the number of nickels I have times 0.05 equals 55 cents. You might say, well, why did I have my coefficients like that? Well, let's look at it, right? If I had 1 dime, the cent value of my dimes would be 10 cents. If I had 2 dimes, right, if this was a 2, then the cent value of my dimes would be 20 cents, right? Because we're multiplying the number of dimes we have by the value each dime is worth. And the same thing goes for the nickels. But now that we've done that, how do we go from here, right? What do we do? Well, essentially, I want to be able to get one variable by itself. Find that value and then plug that back into one of the other equations for that value. But before I do anything, I'm going to want to simplify this equation right here. It's got all those decimal points, and that's really messy. So, what I'm going to do is multiply this entire second equation by 100, right? So I'm going to multiply it by 100 on both sides. That gives me 10d plus 5n equals 55. Then I'm going to multiply this equation right here by 5. So when I subtract these two equations, I'll entirely remove my n term. I'll only be in terms of d and a number, which means I can solve for d. All right, so I'm going to multiply by 5 on both sides, and I get 5d plus 5n equals 35. Try them for both sides. I have 5d equals 20. I'm going to divide by 5. And I get d equals 4. I'm going to plug this value back to my original equation just because this is the simplest equation of the two. And I find that n equals 3. So I have 4 dimes and 3 nickels. All right, so important things to keep in mind. We had to find a way to cancel out one of our variables. We did that by playing around with the coefficients. The first thing we did, however, was make our coefficients easier to play around with, right? In this case, we had decimals, and we didn't want to work with decimals, so we multiplied by 100 to remove the decimals from every single variable. This is a great strategy especially if you're working with decimals. Then we looked and saw, hey, if I multiply by this equation by 5, I'll have 5n and 5n, which means if I subtract them, I'll have no n, right? Another very important strategy. Look for the places where you can cancel out variables. Look for the ways in which if I multiply or divide by a certain number, I can get variables that have the same coefficient in different equations. A very, very valuable strategy. So let's do another version of this, another variation. Of this type of problem. So let's say this time I have 11 coins in my pocket, and they are all either dimes or nickels. And the value of the coins is 70 cents. How many dimes and nickels do I have? So we're going to follow the same basic strategy. We're going to multiply by 100 here, just to make our job a little easier. I'm going to multiply by 100 on both sides to get rid of that decimal. All right, so I have 10d plus 5n equals 70. I notice, well, if I multiply by 5 here, I can get 5n and 5n, and if I subtract them, I'm left with my answer. So I'm going to subtract that from 5d plus 5n equals 55. I get 5d equals 15, d equals 3. Plug that back into my original equation. 3 plus n equals 11. I'm going to subtract 3, and n equals 8. So I have 8 dimes and 8 nickels and 3 dimes. So you can see we follow the same basic strategy of multiply by 100 to get rid of those decimals, and then find ways in which we can manipulate the coefficients to make our job easier. And that's the format you want to follow for any coin problem, and really for any simultaneous equation problem. Anytime you're given a simultaneous equation problem, the first thing I would do is always say, how can I simplify my coefficients? Because if you do that early on, you're going to make the actual work of solving and doing all the adding and subtracting and division a whole lot easier, and you'll be able to solve the problem a whole lot faster. That's all I have. I hope you found this helpful, and I hope you have a great day.